Alright, so here's what I need you to do at this point. No pencils anywhere on your desk, completely clear those off. If you want to get a colored pen that you personally have, or take one of the markers or colored pencils out of the boxes, then do that, and I'll explain what we're going to do from there. Okay, so the pencil's completely cleared off. Grab a marker or a colored pencil out of the boxes. Okay. Alright, so here's what we're about to do. We are going to go over this demonstrate your understanding immediately, because what do we got tomorrow? A test, right? So we need to go over this so that you have some feedback before that test, so you can use this to study. The intent was that we took it yesterday, but we needed some more practice. Apparently some of us still need some more practice. One thing I need to emphasize and remind you is this. I've told you up front what I need you to learn, right? Where do you know, what can you use as your study guide to study for assessments? The purple sheets, the proficiency scales, and use your notes to help you actually do it. I want to remind you, we watched that video yesterday on learned helplessness. I don't know for sure, I don't know, I can't get inside y'all's heads, let's be real, most of us don't want me to get inside your heads, but looking around the room, about half of us did not give ourselves a chance on this one. And I don't know if it's because we didn't study or anything like that, but I need us to actively engage in this conversation that I'm about to have. I need us to study, and I need us to write notes as we go over these problems so that we can improve our understanding before that test tomorrow. Because every single one of you is capable of mastering this, but we got to actually take the notes. So if you need to ask a question, ask that question. I'm going to try to address some things that were already asked during that. So remember, this is what the study design stuff is on tomorrow. This is 1A. You got to know categorical, quantitative questions, or data, statistical, non-statistical questions. That was on the last demonstrate your understanding. We got to know those differences. We also recapped it yesterday. If you go and watch the video I uploaded to YouTube, it's there. All right. Then this is all the stuff with observational studies. These are the things that you have to be able to do. And also, I guess I didn't have it on here, but the 3 different types of bias: undercoverage. Do we do undercoverage in here? Voluntary response bias and response bias. Does that sound right? Yes? Okay. Thank you. So there's 3 different types of bias. That's in the Skew the Script lessons, right? Go look at the resources you have to study. Now, I meant to talk about this before, and I can't believe I forgot to, but one of the things that I do hear from students pretty regularly is that we just don't know how to study for math. So does anyone in here actually study for math and have a strategy that they would recommend or share with people? Mason's like, I don't know what studying is, period. Not to mention math. Does anybody study? So we need to look at the definitions. Bree? Okay, so go over the notes. Okay, so hear me on this, okay, and if you trust me on this and you do the thing I'm about to tell you, it's going to help you master this a whole lot more. Yes, we need to know our definitions, because everything is rooted in what the thing is, right? And that definition tells us what the thing is. So you got to study that. Spend 5-10 minutes a night studying those things. But you can't just know the definitions, you also have to be able to apply. Do the check your understanding questions as well. You got to know what the thing is, and you got to practice it to develop what's called procedural fluency. If you haven't practiced identifying sample population characteristic of interest with the problems I've already given you, then it's going to be hard to actually do it, even if you know the definitions. So make sure you take the time to study the vocabulary. You got to know that, because that's the foundation to being successful with actually doing the thing. Use that to study. Y'all got it, advisory, 25 minutes next time, right after this block. Take advantage of that. Look at some things tonight. We're going to give these back to you. Use that to study. But you got to know all of this, and don't forget the whole goal is to make an inference about the population, but bias can cause issues. That's why we need randomization and ways to reduce bias. Then we got into experiments, and experiments were all about using treatments to determine cause and effect, but we had to reduce confounding to make that happen. And we had a few strategies down here to help us reduce confounding. But again, you're going to have to actually practice identifying the explanatory and response variables, practice identifying the units and the treatments. And Deshaun, being able to actually do that goes back to what again? What did you say earlier that you need to study? The definitions, right? Our responses need to be rooted in those things. And so now we're on these normal distributions. We're going to do this demonstrating understanding right now. So I saw a lot of circled answers, right? And I want to point this out. Let's say that you circled B here. First off, if you just circle that, is that evidence that you understand? No, you got a 25% chance of guessing it. By the way, is that going to be a normal distribution? What's the problem there? To what? Two hills. And remember, and so like that could be evidence of why it's not that, but there's an actual term. What? This is bimodal. If it's bimodal, it's automatically out. Notice, that's some evidence of understanding right there. I am showing, with the simple word bimodal, I know that this is not normal distribution. That shows me that you understand what normal is. So, if you didn't know how to show evidence, justify your response, that's a good way to do that. Okay, what about A? Could A have been normal? No, but it's not bimodal, it's unimodal. What's the issue? It's skewed right. That's the problem here. Remember, it's about the longer tail. Okay, so that's skewed right, not normal. Did anyone pick C, or did we go with D? You went with C? Why are we thinking C, Deshaun? It's symmetrical and unimodal, so did you pick D as well? What? You don't think so? Okay, Tyler, what were you thinking? You were thinking D. Why?
C looks more like uniform instead of...
Okay, any other thoughts? Bree?
I say C because it's like a bell shape.
Okay. Okay. Any other thoughts? Okay. I would say this. Did you write down that idea about empirical rule?
Yeah.
Did you write down that idea about bell-shaped? So that's strong evidence of understanding. However, I will say it does need to be D. The normal distributions are not going to flatten out like this. Okay. So remember, if you ever drew a normal distribution, did you ever have it flatten out at the top? No, right? So strong evidence of understanding if you wrote that, right? Like that's one of those things that even if you pick C, I might say a CE for clear evidence of understanding because you're talking about the empirical rule, a key idea for a normal distribution. So it's not just about getting the answer right or wrong, it's about what evidence do you show. So you'd have a small p next to it indicating a procedural error. Same thing, Bree, right? Strong evidence, bell-shaped idea. That's why we justify our responses. So we know A and B are out. We know this one is bell-shaped. This one actually is bell-shaped. This one would follow the empirical rule. Okay? It's unimodal and symmetrical. All of that stuff would be good. What's the issue again with C that we'd want to pay attention to? It flattens out, right? The flattening out is the problem. So just keep that in mind, that a normal distribution is not going to flatten out like that. And be careful, it's not uniform. Tyler, you the one that said uniform? Uniform means it's the same all the way through. It does flatten out at the top like uniform, but it's not uniform. Does that make sense? So notice that right there, one single question that was multiple choice, I have shown clear, consistent, convincing evidence that I know what a normal distribution is and whether something's not normal. That tackles a lot of ideas on the proficiency scale with just a couple of simple words. Use this to study and know what it means, right? So, and don't forget the skewed right because of the longer tail. Any questions that I need to answer at this point? KJ, you with us? You alive?
Yep.
You want to take some notes?
I ain't got stuff.
What'd you do with it?
I forgot my bag.
But, what? I mean, I get that, but how's that affecting you from taking notes right now? There's markers in that box right there. If you're not taking notes, it's because you don't want to. What did I do with that remote? Oh, thank you. Yeah, I was looking everywhere else. All right, so second one. Number 2. When we deal with this idea of a normal distribution, what was the recommendation I gave from the beginning to help provide evidence of understanding?
Right off the number.
Draw that normal distribution. Every time you draw it, it gets easier and easier and easier. So draw that normal distribution. Now, at the same time, I will say this. Do I really need to draw the normal distribution here for part A?
No,
Why not?
because as you standard deviation of 1.
Right. It's just between one standard deviation below the mean and one above the mean, and what's always between one below and one above? 68%, right? I don't even have to draw anything out. Could I write a short sentence to justify that?
You can.
I could, right? Maybe even start here at the top. Just writing this out at the beginning, is that some evidence of understanding for all 3 pieces? Right, like show me you know what the empirical rule is and what it means. Like just writing 3 numbers out, 1 is going to help you focus your attention, and 2 is going to help with justification. But 68% of data in a, now be careful, remember it has to be a normal distribution. A normal distribution is within what percent? Or is within how many standard deviations? 1 standard deviation of the mean. Didn't have to draw a single thing. I know it's within 1 standard deviation. Now, you could technically do something like that with part B as well. Bless you. Okay, so we need to know 68% within 1 standard deviation of the mean. What percent of data is within 2 standard deviations? 95%, and within 3, 99.7. It's 3 numbers, guys. 68, 95, 99.7. We gotta know that. We spent 3 days on that. Just those 3 numbers. We gotta know that. Okay? Now, for those of us who are struggling on B and C, this is where I would draw my normal distribution. The more you practice drawing it, the better it's gonna get. And don't be scared to get things wrong or to have trouble. That's okay. Kayla, I think you were the one asking me earlier, like, I don't know how to draw this, right? Like, to put in those values. Okay? So, where am I going to start when drawing a normal distribution? I'm going to start with the mean. What's the mean? 7 hours, right? Okay? And then, what's 1 standard deviation?
0.7 hours.
0.7 hours, right? So, what point am I going to try to look for along in here to find 1 standard deviation?
Where it starts to flatten.
Not where it starts to flatten. So it is going to be even here, but does anyone remember that point I pointed out? It's where the concavity changes. That's called a point of inflection, right? Remember, it's concave down through here, maybe in this region. See, before that, it's concave down. You hear me talk about concave down like a frown when we get to quadratics. And then after this, it's concave up. Like if I continue this, it would almost look like a cup. Concave up like a cup. So, 1 standard deviation. And I take my distance, and I repeat it, and I repeat it. And we take that distance, and just keep repeating it. It's going to give you your standard deviations nicely. May not be perfect, but it helps. Okay. So my standard deviation was 0.7. So if I go 1 standard deviation this way, Jakayla, what am I going to get? My standard deviation was 0.7.
Right.
So I'm going to go to the right, but like, what would the value be then? Okay, so that's where we're having difficulty.
Yeah.
Let me ask you this. On a number line, when you go to the right, are you adding or subtracting?
You added.
Okay, so what's 7 plus 0.7? Got calculators. That's why I said we need to get calculators from the beginning. So you can also go grab a calculator.
7.7.
There we go, right? And you know what I'm going to do when I go to 2 standard deviations?
Yep.
I'm going to add another. What am I going to add? What am I adding? 0.7 again, and what do I get?
8.4.
8.4. Add 0.7 again, you know what I get?
9.1.
That's it, right? Like, that's why you gotta know what your standard deviation is. And now, when I go to the right, I add, and when I go to the left, what am I gonna do? Subtract. 6.3, 5.6, and 4.9. Remember, the mean is 0. The 7.7, that was 1 standard deviation above the mean, 2 standard deviations above the mean, 3. 1 below, 2 below, 3 below. This is going to help me with my empirical rule. If you can draw that normal distribution, that's going to help a ton. And I would do that every time I look at something like B and C. So what am I looking at? From 7 hours to 9.1. I'm going to put a mark at 7. I'm going to put a mark at 9.1, and then I'm going to shade all that. And so remember, this is all based on the empirical rule, right? So Andriana, which part of that empirical rule do you think I'm going to use if I'm going all the way out to 9.1? Am I going to use the 68, the 95, or the 99.7? 99.7? Why do you think that? Because it's on the what? Yeah, it's going pretty far out there. There's another reason why we might think that. Kayla, do you know why we're going to say 99.7? Mason? Why are we using 99.7? Did you use the 99.7? Guys, we gotta, like, when we're in small groups, we gotta, like, this is no different than the problems we did yesterday. When we're in small groups, we gotta make sure we're asking these questions. Tyler?
It's 3 standard deviations away.
9.1 is what?
3 standard.
3 standard deviations away. 1, 2, 3. Use 99.7. That's it. So like, if I was at 5.6, I'm going to use that 95 somehow. But I'm at 9.1. Notice I am at 7, so that's not 1, 2, or 3, but I am at 9.1. So I'm thinking something about that 99.7. Now, am I using that whole 99.7 though? Bree, you're saying no. Why not? I got a half it. Remember, 99.7 is from here all the way up to here. But do I have this left half at all? That's why I say the left half. So Kayla, what am I going to do with that 99.7 if I don't have the left half? I do have the right half, I don't have the left half. Say again. Add or subtract what though? Okay, I'm going to come back to you in a second, and Jade, I'm going to get you to answer this in a second, but I do want to point this out. What I literally have is half, right? I only have half of it. Okay, you good with that? Only the right half. I have half of 99.7. So Jaden, what did you do with that 99.7? You what? Divided it by what? Be careful with the language. You divided it by 2 to get half. One thing I want to point out, and I need everyone to notice this, if you ever have in math a percent of or a fraction of, you know what that word of translates to immediately? Bless you. If you have a fraction of something, then you multiply it. Dividing by 2 is the same thing as taking half of 99.7. That's it. If you recognize, hey, I have a half of 99.7, 1/2 times 99.7 every single time. If you have half of something, Kayla, if you have half of something, what are you going to end up doing? What mathematical operation?
Divide by 2.
Look up here again. The whole conversation I just had was we would do something different. We would never do this, but if I were to say I have 2/3 of 99.7, what would I do? Andriana? 2/3 times 99.7. Because mind you, if I have a fraction of, what does that always translate to? What did Andriana just say?
Did you want me to say that?
I was asking you, what is was the fraction of always translate to? Okay, I'm gonna come back to you, Jakayla. I'm gonna come back to you. Jakayla, actually, this right here, Jakayla, if I were to say 3/4 of 99.7, what am I gonna end up doing? Alright, I'm gonna come back to you. Deshaun, what are we gonna do? We're gonna multiply it. So Samaja, Jakayla, when I have a fraction of, what do I end up doing?
I multiply.
That's it! Every time! Samaja, if I have a fraction of, thank you, I'm gonna multiply. You see a fraction of something, just multiply it. Okay? And in this case, yes, it is a type of division, because you know what that fraction bar is? What it means? It means to divide. That's why there was division by 2, but it's a fraction of divide. Or multiply. Okay, so what is half of 99.7? 0.85%. And Deshaun asked, should we put context in? Yeah, if you want to put context in, that's how you get to that clear, consistent, convincing evidence of understanding. But if I just ask the percent, you can just report it as 49.85. And I might do that to start and go back at it and add context later if I have the time. Okay? But 49.85%. Now, if I were you, every time I'm going to redraw a normal distribution, because I had to shade that, right? But the more you do it, the easier it gets. There's my normal. Mean of 7. Standard deviation of 0.7. And alright, so we have a battery life between 6.3 and what? 8.4, so 6.3 to 8.4. Looking in between here. Adriano, which part of the empirical rule, the 68, 95, and 99.7, am I going to use here? I'm going from 6.3 up to 8.4. You want to say 68? What's telling you the 68? So -1, 1 standard deviation below the mean. That's telling me something with the 68 for sure, right? And there's other things that we can do, because I will point this out. Am I just going to be using the 68% here? Why not? It goes up to 2, right? So I need to use the 68 and the 95% somehow. And there's multiple ways to do this. Lane was playing around with it and finding those pieces yesterday. For me, personally, I'm just always going to do this. Now look at the mean. How much is this part of the 68%? What fraction is it of the 68? It's half of 68. Yes, 34% right here. What's this right here? Half of what? 95. There it is. I add them together. I get 81.5% of all the tablets have a battery life between 6.3 and 8.4 hours. So, again, just what Andriana talked about there is great of, hey, I have 1 standard deviation, so I'm going to do something with that 68%. We just have to recognize, okay, I'm going from -1 to 2, so I need to use the 68 and the 95. And I'm just going to look at halves of it. Again, because there's symmetry here, so I know around the mean that's half of 68, that's half of 95, and I just put those halves together. It's the easiest way. in my opinion. There's other ways to do it, for sure. But to me, that's the easiest. And by the way, can use calculators for a lot of this work. Guys, I've been doing empirical rule, I've been teaching empirical rule since I think 2015, 2015, somewhere in there, so 10, 11 years. So I know the fractions of the empirical rule really well. I know how things add together really well. Because in doing something for 10, 11 years, you just kind of learn those numbers. You don't have to memorize those pieces. As long as you know 68, 95, 99.7, you can break it up using a calculator. Please take advantage of that. All right, we got to move quicker so that y'all can get some practice with the study guide before the end of today. Number 3, I need y'all to be careful. A lot of us got the mean perfect, but some of us missed the standard deviation when I was walking around. What's the mean here for sure? 140, right? How do we know the mean is 140? It's in the middle, right? So mean is in center. Notice, very quick 4 words to indicate why I know that that's the mean. It's in the center. That's what you had to think logically to get there. So just write it down. Okay? It's in the center. It's the mean. Now, is the standard deviation 5, 10, or 30?
10.
Why do you think it's 10?
Because you could subtract 150 from 140.
Yeah, but why aren't you using the 145? How do you know it's too close?
Distance.
Something I'm looking for.
Oh,
There's 2 major ways you can justify it.
this is the first standard deviation.
How do you know that that's the first standard deviation, though?
Because where the top would be located on the slope.
So you're talking about kind of connecting to here? So like if I draw a line here, what kind of point am I hitting right here?
Oh,
So it was concave down before that, but it's concave up after that. So this is the point of, that point of inflection marks 1 standard deviation. The other thing I will point out is roughly how many standard deviations should we have on either side of the mean? We should have roughly 3 standard deviations on either side, right? If I were to use the 40, 145, 155, 165, I would get 1, 2, 3, 4, 5, 6, right? I'm only supposed to have 3 standard deviations. So that standard deviation had to be 10, not 5. So remember, that point of inflection tells us where 1 standard deviation is. That is something, if you know that detail, it makes the rest of this significantly easier. Now, I saw a lot of us write down what the mean and standard deviation were here on number 4. I didn't see a lot of interpretations. When you interpret, when I ask you to interpret, there's 2 things you got to put with that number. One, what was that thing, Deshaun, that you said you like to study? The definitions. You know what you need to include in the interpretation? The definition. Like, what is mean? It is the average. What is standard deviation? It's a typical amount of change from the mean. Okay, we got to include that for the interpretation. Definition, but 2, these aren't random numbers. We have to include the what? Units, yes, there's a little bit more I would say with it. Context. Not just units, right? Because we're talking about inches, sure, but like when we're talking about inches, are we talking about someone's height? Are we talking about their inseam? Are we talking about their waist? Are we talking about the distance around their arm, their wingspan, right? The idea of inches can be anything. We need more context with it. So, The mean, the definition of mean is average. Average what? What's the context? Height. I need a little bit more.
The 8-year-old.
Yeah, it's all about those 8-year-old girls. You could even include the school district, but I'll just say it this way. The height of the 8-year-old girls is what? 50 inches, right? You do have to include units because is it 50 feet? Is it 50 inches? 50 centimeters? 50 yards, right? Like there's lots of options. That's it. That's mean. I've got the definition. I've got the context. Standard deviation has a little bit more involved, but we got to know this. This is part of the foundation piece, I believe. This is the definition is the typical what? Change or difference from the mean. That's the definition. The typical difference from the mean is, and I've already talked about the 8-year-old girls, so that's fine. You don't have to rewrite it. But what is the typical difference from the mean? 2.5 what?
Inches.
You do need to include those units. That's interpreting. Putting context and the definition with the numbers. The beauty of real world is it's real world. We can't ignore it. We gotta talk about it. That's how you interpret every time. It's gonna be different context, it's gonna be different numbers, but it's pretty formulaic. The average height, the typical difference from the mean. You got all that down, Mason? You got it all down so you can knock it out of the park tomorrow? And then with B and C, notice I am not just doing pure percents, I'm doing a percentile. When we see that word percentile, what do we need to think? It's at or not above, less. At or below, at or less. Make sure with percentiles we're thinking at or less. So a mean of 50, I marked my mean. Standard deviation of 2.5. And just to save myself a little bit of time, I'm actually just going to go to the 55 right here. Because what am I going to shade? Everything to the left. When we say percentile, it's everything, it's at or less. So Mason, 68, 95, or 99.7? Which one? I can't hear you.
99.7.
Okay, why do you think 99.7? I mean, 95% though is a lot as well. So how do you? So I can see why from that logic you're saying not 60. You're not saying 68, but how do we decide 68, 95, or 99.7? That's within how many standard deviations? This is within, and this is within. Am I going to 3 standard deviations? So I'm not using 99.7. What am I using? 95. Again, there's multiple ways to do this, but personally I'm going to play a game of halves, because what's always the left half, or everything to the left of the mean? 50%, right? I know this left half is 50%, it's half the data. This is half of, what again, Mason? Is half of the, remember this right half, you said we're going to use which part? So there's going to be half of, so they are at the 97th, I would also accept 98th percentile. They're at the 97th or 98th percentile. That's all it is. It's the percent at or less. Notice I didn't leave it as a percent though. I rewrote it essentially as a percent, but at a percentile. Now this next one's a little bit trickier because it's asking us to go in reverse, but it doesn't change much. We just have to figure out where we're shading. So what percentile are we looking at in part C? 16th, right? Okay, so first off, it's the 16th percentile. Is that going to be to the right of the mean or to the left? It's got to be less than half, right? So logically, let's just think logically about it and then we'll check ourselves. Are we thinking 16th percentile? Is it 1, 2, or 3 standard deviations below the mean? How many? I think I heard 1. Yes, that's what Bree was saying. So I will point out, let's check to see if it's 1. So if it is 1, first off, we already know that to the left is 50%. What's right here? What percent of my data is right here, the percent that I don't want? Remember, that's half of that 68, right, or 34%? Hey, what's 50 minus 34? Say it louder. 16%. Okay, so what's the value right there? 47.5 inches, right? It's just taking the percent, we found the 16%, and then I find the value that goes with it. Notice, we're looking for a height this time. I gave you the percentile, we're looking for the height. That's it. I'm going to give you a few minutes to finish writing your notes, but once you're done with that, put all of your papers together. Ms. Kowalski, if you could run and make scans of them so we can hand it right back to y'all. That's why you need to write the notes you need to write. After that, get your study guide out, and I'm going to have y'all split into 2 major groups. Okay? Yes, definitely have your name on there so we know whose it is. So do notice that little arrow was me showing here, like we know to the left of the mean is 50%. So when we found that this was 34, 50 minus that 34 gives me the 16% right here. That's the whole idea. Okay? So I need us to get our study guides out once we're done taking our notes. What I also will say is this. If you feel like you need to work on study design, so observational studies, surveys, experiments, I want you to move to this side of the room. If you feel like you need to work on normal distributions and the empirical rule, I need you on this side of the room. So once you get your study guide out that we gave out yesterday, I need you to move to one of those 2 sides of the room.
I'm neutral.
Huh?
I'm neutral. I need to learn anything.
Okay, can you learn everything all at once?
Oh, you got that.
Jordan, we passed them out yesterday.
Yeah, I don't got
Where'd you put it? Where'd you put it?
I ain't had one when I walked in. Oh,
We didn't pass it out till the end of class, Jordan. So if you don't have one, then you didn't take it when Miss Kowalski passed it out. Have you looked for it in your bag? Oh, you don't have your stuff at all. So I'll get you your stuff. But here's the thing though, you can't do everything all at once. Pick one side to start with. Okay? So study design over here, normal distributions over here. And here's a copy of the study guide for you. Right here. Now, normally I do not pass out a study guide. Normally, I expect you to use your check your understandings. However, I decided to be nice this time. Use your check your understandings and your resources from class in the future.